All right. This is Algebra 3, Lesson 38. Starts on page 269 in your book. Deals with fundamental counting principle and permutations, designated roots, overall average rate. Okay. Let's see. So questions 1 and 2 are talking about fundamental counting principle. You learned about the fundamental counting principle in Algebra 2, so that's why I say this is a review. A quiz has 4 possible questions. If each question has 3 choices, how many outcomes are possible? So we look at something like this, where we ask ourselves, well, how many questions are there? 4 questions. Here's question 1, here's question 2, here's question 3, here's question 4. How many outcomes are possible for each question?
3.
Read the question, right? You've got it in front of you. Don't guess. 3. All right, so there's 3 possibilities for question 1, 3 possibilities for question 2, 3 possibilities for question 3, 3 possibilities for question 4. So how many possible combinations are there? Well, 3 to the 4th or 81. Not. Okay. To kind of maybe give you a visual of this, right? How could we get this? Well, let's say question number 1 has an A, a B, and a C option. All right. Then question number 2 could be A, B, or C if question number 1 was A. Right? Question number 2. And the same thing here. A, B, C, A, B, C. Right? This second column is possibilities for question number 2. So I have 9, right? That gets me to 9. So by the time I got to question number 2, there's already 9 different possibilities that could take place, correct? And then by the time I get to question number 3, right? Do we see how real quickly we can get to 81? Okay? We understand why it's multiplied. Okay, great. What's that? Okay. All right, question number 2. A quiz has 3 multiple choice questions if each question has 5 choices. All right, so how many questions do we have? 3. 5 times 5 times 5, or 5 cubed, or 125. Okay? But you need to understand how the question is worded and what it means, because otherwise somebody will end up with 3 to the 5th, and that's not 125. All right? So how many of something there is, that's my line.
So if it says they have 5 choices and there's 3 multiple choice questions, it'll still be 5.
There are only 3 multiple choice questions, so that's my category. 3 multiple choice questions. Question 1, question 2, question 3. The sum, right, is how many options each question has. Does that make sense? Okay. All right, so do we understand the fundamental counting principle and permutations? Okay. Let's see. I don't think that they're giving you anything more well, when we start talking about permutations, and I don't see where a question comes up in this stuff, but permutations can be a matter of if repetition is not permitted. Okay? If repetition is not permitted, right, let's say I have those 3 questions, but they're all different answers, right? So for those 3 questions, well, the first question has 5 options, but the second question now only has 4 options. So if it went A, B, C, D, E, A, B, C, D, E, right? Let's say I picked A, now I can't pick A. I can only pick, B, C, D, E, right? But on the next one, right, it drops down and I'm down to 3. So if repetition is not permitted, the question changes to 5 times 4 times 3. That's why we're talking about permutations. Okay? So you end up with what? 60, right? So that's the kind of amazing thing is that with constraints, we drop from 125 to 60 possibilities. All right. Now, if there were 5 questions and 5 possibilities and permutation or in repetition was not permitted, we would end up with that factorial, right? Because we'd have, 1, 2, 3, 4, 5 questions, 5, 4, 3, 2, 1 options, 5 factorial equals, and you'd plug that in your calculator. Okay? Or 5 times 4 times 3 times 2 times 1 if you had to. All right. So hopefully we understand that. Okay. Going back here for a second. Um, questions 3 and 4. The reason I said that these are way easier than they appear to be is because it's the verse of solving the quadratic formula. Okay? We work our way back up from the bottom. Okay? So what we're used to doing is seeing a question like, x squared plus, I don't know, let's see, 14x plus 49, right? And getting, x plus 7 times x plus 7. And so my solution is x equals negative 7, right? Okay? What these do is they say, we know that our answers are, in this case, 3 and negative 9. Okay? That means x equals 3 and x equals negative 9. Okay? I'm at the bottom already. I know the answer. So in order to work my way back up, I'm trying to get back to something like this. I'm trying to derive that. So the first step is to move the 3 and the negative 9 back across. All right? Undo all of the steps that it would take to get there. So I wind up with x minus 3, right? And I have x plus 9. And then I FOIL, right? So I have x squared minus 3x plus 9x minus 27. Combine my like terms, x squared plus 6x minus 27. And I think they want these to equal 0. So this is question number 3. Is that as hard as it looked? All right. Now, there are some specific things that they do say in here that tell me that I can do this. It says that the lead coefficient of 1. Okay, the lead coefficient means that lead coefficient. Okay, I know that that's going to be a 1. Okay, whose roots are 3 and negative 9. All right, so can you guys solve number 4 on your own? Okay, I'll leave this up here. You guys solve number 4. I'll hit pause. All right, I got some people with answers, so let's take a look and see what they got. She got x squared plus 7x plus 10 equals 0, right? Make sure we're putting equals 0 on that. X squared plus 7x plus 10 equals 0. X squared plus 7x plus 10 equals 0. X squared plus 7x plus 10 equals 0. X squared plus 7x. If you got x squared plus 7x plus 10 equals 0, you got the right answer. Good job. All right. All right, and our last set of questions here is 5, 6, and 7. This is overall average rate questions. Okay, so it's still rate. It's still dirt, right? Distance equals rate times time. Rate equals distance over time. Time equals distance over rate. All right, but because we're doing overall average distance, overall average rate, we're looking at overall average distance over overall average time. Okay, and that's going to give me my overall average rate. Does that make sense somewhat? Okay, so let me get to a new page and show you how we do this. Okay, Ernest traveled. Let's go ahead and start off with our little formulas. So I like to start with the same stuff every time. And in order to have an average, we have to have more than one thing. Okay, so instead of just trying to change one situation, we're going to be given more than one thing. All right, so Ernest traveled d miles in s hours. So d miles, s hours, okay? All right. Um, D miles in S hours, which means that his rate, well, his rate as it stands right now is D over S, right? Okay. So D2, R2, and T1 or T2. So we have R2 and D2. Okay. Let's see. And then traveled P miles in hours. Okay. If he maintained his overall average rate, how long would it take him to travel 80 miles? So in the end, I want time, right? In the end, I want time. Okay. So we got D over S for my first rate. I've got P over N for my second rate. All right. So time is distance over rate, correct? So what's the distance that we're trying to use here to find our overall, to find our time? 80. Okay. And our overall average rate is going to be D plus P, overall average distance, over overall average time. So S plus N. Okay, like this. Okay. So keep in mind that that's over 1. And then we multiply by the reciprocal. So I get 80 over S plus N over D plus P. Okay, and our time should be in hours. Okay, let's look at the next question. Does this make sense so far? Okay, we got that. Great. Okay, second question. I don't know why I have graph paper strapped to this. Okay, the great runner could travel 9 miles at 3 miles per hour. So his distance, 9 miles. His rate was 3. Okay. Let's see. And then he could run 6 miles at 6 miles per hour. Okay. What should be her speed for the next 5 hours so that her overall average speed would be 4 miles per hour? Okay. So I'm going to go ahead and figure in our time here, right? Time is distance over rate, correct? So what's 9 divided by 3? 3. So it took her 3 hours to run those 9 miles. We can figure that much out. Okay? She was running 6 miles at 6 miles per hour. Time is distance over rate. How long did that take? 1. Okay? All right, going back to our question here. What should be her speed for the next 5 miles so that her overall average speed would be 4 miles per hour? Okay? Well, speed, rate. Rate is what? Distance over time. Okay? So far, we have 9 plus 6, right? And they say over the next 5 miles, right? What should be her speed for the next 5 miles? Okay? All right, so 9 plus 6 plus 5, what is that? It's going to take a long time.
9 plus 6 is 50, plus 5 is 20.
All right, so overall, 20, right? So, let's just kind of common sense this through. If I want my speed to be 4 miles per hour on average, we already know our overall average distance. What has to be, right, my distance over time? What has to be my time? My time has to be 5. All right? But so far, right, look, we have 4 hours spoken for, correct? Right? 3 plus 1 plus x. Please stop. Okay, so 3 plus 1 is 4. Okay, 4 plus x equals 5. What does x equal? Are you serious?
1. Yes.
Okay, x equals 1. Okay, so what was the question? It says, what should the runner's speed for the next 5 miles be so that the overall average speed would be 4 miles per hour? Okay, so our time would have to be 1 hour, right? Remember that our next distance was 5 miles, correct? Our time was 1 hour. What would have to be the rate, the speed that she's running those 5 miles in if she's going to do it in 1 hour? Well, rate is distance over time, correct? Okay, so what's 5 divided by 1? So she needs to run 5 miles per hour for the next hour so that her overall rate for 20 miles is 4 miles per hour. Are you lost? Yes, I lost you. Okay, let's start again. Okay, I'm not going to rewrite anything, but we understand 9 miles, 3 miles per hour is 3 hours, right? Okay, the second distance, we said 6 miles. It was taking 6 miles per hour. It was only going to take 1 hour. We solved for those two, we solved for the 3 and the 1. Okay? Then they said the next 5 miles. So the next 5 miles, okay, that's my distance. Okay? We want our overall average rate to be 4 miles per hour. So overall average rate is overall average distance. So 9, or is overall distance. 9 plus 6 plus 5 is 20. Okay? We've already gone 4 hours, right? So in order to get 20, we're saying 20 divided by what? 20 divided by what equals 4? Well, we knew that that had to be 5. Okay? We've already got 4 of them spoken for, so my time has to be 1 hour for this distance. Okay? So that rate equals 5 over 1. So rate is 5 miles per hour. Does that make more sense that second time through? Okay. All right. All right. One more. Number 7. Unless you want to skip it and do a question from your homework. Okay. All right. Question number 7 on this page is really similar to question number 5. You'd solve that the same way. All right. Let's see. What was assigned in your homework? All right. 1 through 10. So 6, 7, and 8 are all permutation questions. So for instance, number 6 says how many 3-letter signs can be made from the letters in the word Hamlet if no repetition is permitted. So notice that there is no repetition already there, right? There's no letters that repeat. So we're saying 3-letter words, right?
Yes.
From Hamlet. Well, how many letters are in Hamlet?
6.
Okay? 6. So 6 times 5 times 4 because repetition is not permitted. So what? 30 times 4 should be 120. Okay? So do we feel like we would understand? Now, number 7. Notice the difference there. What's different about number 7 from number 6? Repetition is permitted, right? Okay? So 5-letter signs. And how many letters does Lefty have in it? 5. So it's 5 to the 5th. Does that make sense? Okay, because repetition's permitted. That's number 7. Let me see. Do you want to see number 12 worked out? Is that yes or no? 12, because we haven't done a summation question in a while. Okay, so we've got 3 summation k equals -1 for k squared over 4 minus k. Okay, so this is my minimum, this is my maximum. I don't feel like everybody who's asking for this is necessarily paying attention. All right, so we have negative 1 squared over 4 minus negative 1. Okay, that's the first set here. Plus, okay, then we would go up to 0. 0 squared divided by 4 minus 0. Okay, plus 1 squared over 4 minus 1. Plus 2 squared divided by 4 minus 2. Plus 3 squared divided by 4 minus 3. Then I would get all of that, combine it together. Okay? Probably. We probably did do it. Okay. All right. Well, negative 1 squared is 1, right? So I'm getting 1/4 plus 1. All right. So it should be what? 1 and 1/4. 0 squared, that's 0. There's nothing to add there. Okay, because 0 squared is 0. 0 divided by anything is 0. 0 minus 0 is 0. 1 squared, this is where I'm getting what? I have 1/4 minus 1. 1/4 minus 1 would be negative 3/4. Something like that. 2 squared is 4. 4 divided by 4 is 1. 1 minus 2 is negative 1. 3 squared is 9. 9 divided by 4 is 9/4. 9/4 minus 3. That would be like, I don't know. You guys can do the rest. I'm not going to try to do the rest in my head. Yeah, but the problem that I've seen with doing it in your calculators, I've seen calculators get the summation questions wrong. So I don't know if there's a setting that's messed up, but this is the one place where I really haven't been able to trust a graphing calculator. So you honestly need to be able to do summation questions pencil paper. Okay? No, okay, so see where the K is? All right, I'm increasing each set by 1 until I get to the maximum. The maximum is 3. So negative 1, 0, 1, 2, 3. But if I have multiple Ks, I've got to do that all the way through. The bottom one here is minimum. It tells me where I start from. So that's why I started with negative 1 for K, for each K, and went up and stopped at 3. Got it?